Okay, so in part A, they want you to find all the values of t. It's got to be in this interval from 2 to 4, for which the speed of the particle is 2. Okay, so remember, one thing we need to remember about speed of a particle, that's equal to the absolute value of the velocity. Now, this is a calculator question. So in your y1, I would just take the absolute value and then put in the v of t equation and start by getting a picture. Okay, so maybe you want to pause me and see what you get as a picture. All right, so this is what my v of t equation looks like when I take its absolute value. Now, they basically want you to find all the values of t for which the speed is 2. So in other words, I'm going to go back over here and I want to figure out when that is equivalent to 2. When does this equal 2? So again, this is a calculator question. So along with putting the v of t in your y1, in your y2, I would go ahead and I would plug in your y2, 2. And when you do that, you're going to see that you have 4 points of intersection. 1, 2, 3, and 4. Okay, now, but let's read carefully. It says we want the values of t between 2 and 4. Well, this one's less than 1, and so is this one also. So we must only be looking for these two guys right here. Okay, so why don't you go ahead and figure out what time this is and what time that is. And these are your two values right there. So there's your answer to part A. All right, so this is a two-part. So the first part wants an expression for the position. Well, we know that the position is the integral of the velocity, right? And the other thing we also know is we have an initial amount. So we should start with 10 plus, we're going to integrate from 0 to some time t, the v equation. So v of x dx. Okay, so if you read the first question, or the first sentence, it says write an expression involving an integral that gives the position s of t. So there it is. Now it says to use that expression, so here's my first answer, and to evaluate or find the position at time 5. So basically what they want is s of 5. So 10 plus the integral from 0 to 5 of your v of t equation. Well, all of this can be put into your calculator, can it? So put that part into your calculator, pause me, and see what you get. All right, so I have negative 19.2073. So then my final answer for s of 5 will be negative 9.2073. There's your answer to part B. Okay, so part C is asking you to determine times when the particle changes direction. So let's think about this for a second. How do you know when there's a change in direction? Does that involve position? Does that involve velocity? Does that involve acceleration? And hopefully you are saying that involves velocity. And there would be a sign change, right, when there's a change in direction? Well, again, this is a calculator question. You can go to your y1 and just plug in your v of t equation. Now be careful, because currently what's in your y1 is the absolute value of the v of t equation. We don't want that. We want the actual v of t equation. So get that absolute value out of there. Put the regular v of t equation in your y1, and you should get something that looks like this. Okay, now we're looking for changes in direction. So wouldn't we have a change in direction from below to above the x-axis right here at this time? And then again over here, we're going from above to below. So what you need to do is find those two values. So why don't you pause and figure those out? All right, so those would be your two values of t. Now it also says to justify your answer. And the reason would be below here. So at those 2 points, because the velocity changes sign about these points, signifying a direction change. Okay, so part D is also referring to speed like it was in part A, but this one's different because it's asking if the speed is increasing or decreasing. Now remember, there's a couple of things that we need to know if the speed is increasing or decreasing. And by the way, it also says at time 4. So we would need to know V of 4, and we would need to know A of 4. So, well, you already have the velocity equation in your y1. So take that and you can evaluate that. So you can go to your home screen and do vars, y vars, enter, enter, and then parentheses 4. Close the parentheses, see what you get. All right. I have negative 11.4757. Okay, so now to do A of 4, you can go to your home screen and just do math 8, because remember the acceleration is the derivative of the velocity, and then evaluate that at x equals 4. Okay, why don't you stop me figure that out? I have negative 22.2957. Okay, so what do you notice about both of these? Do you see that they have the same sign? So what happens if they have the same sign? What is the speed doing? Speed is increasing. Okay, so if the signs were different, then the speed would be decreasing.